Okay, so network operations. So several things. So we've done a lot of work, network operations, resume rankings to determine which resumes were kind of closest for or best matches for jobs. We have done kind of like movie editing. This is like artifact identification. So when a movie has been shown, sometimes you see like reflections of a camera in a mirror or something like that, or in a window, or you see a crew person somewhere as a reflection there, or a boom mic or something. So being able to pick that out. Consumer recommendations. This is for, in this particular case, it was for cosmetics, market forecasting, using body cam videos, identifying tumors or pathologies, as my wife would insist. And then also on satellites to be able to, so instead of beaming down data to a ground station for analysis, to actually analyze the data on the satellite so that you minimize the amount of data that needs to be transmitted. So, in terms of availability, so in terms of cloud, AWS, Azure, SageMaker, we have like the PIMs can run on all of these environments. AI Studio can run. The only time our runtime is not applicable is inside SageMaker, because SageMaker combines both the like it's AI Studio and the runtime in one container, so you don't need to worry about it. It's like it's not applicable there. ARM64, a PIM can exist there. We don't have AI Studio on ARM. The reason is very simple. You need a lot of compute power, and low power ARM devices do not have that. So you don't need AI Studio there, but you can have a runtime on it. So once you train a model, you can deploy it onto an ARM64 device. We're working with Microchip, and it's a company that builds FPGAs. We're soon going to have PIMs that are available there. We're not going to bother with AI Studio because, again, it makes less sense on an FPGA. And then a runtime will soon be available there. Same thing with Altera. They also have like FPGAs as well. And the rest we have. So on premise, we have everything. We're also producing a NeoPulse appliance, which is a kind of a little supercomputer, which contains kind of really high-end GPUs and optimized motherboard and everything like that for AI Studio, and is designed for training very complex models. So this is on the AI market. We have both on the AWS marketplace, you have a runtime as well as AI Studio. This is on SageMaker. We have, so you'll notice that in SageMaker, it's just simply called the NeoPulse Framework 3.0. We don't have separate AI Studio or runtime because you don't need that. And then Azure, we have, obviously we're there as well. The key question is how to use AI to solve a business problem quickly and efficiently, and also to future-proof it. So, which means you need to build a process in to change it. You need to, basically what this says is you need a process. And lo and behold, we have a process. So this is basically something that was developed by a guy by the name of Deming. Yeah, in the I think it was 1960s. And so it was basically something called statistical process control. And statistical process control eventually became part of Six Sigma, which is a way for companies to build high quality products, and actually a way for enterprises to build high quality products as well. And so the Deming cycle has various iterations, and I've seen you can basically apply this into almost any setting. I've even seen it in a military setting, which is basically, you can kind of already see how that would work. You plan something, you actually execute, you check to see how the result of that, and then you react to that change. So like fighter pilots use this apparently as well, are a variant of this. But basically what the Deming cycle is, so a large part of building a machine learning model is around thinking about the Deming cycle, which is plan, do, study, act, or plan, do, check, act. And so you can start anywhere. So obviously planning would be you do an analysis of the business process, do an ROI analysis, engineering, you check the results, and based on the results, you kind of go back and reanalyze everything. So there's an entire, I can spend probably multiple days just talking about the statistical process control, but I won't. But it is fundamentally the way that you should think about building AI models. Part of this is an enterprise AI team. You need to think about it from the perspective of, so building a centralized AI team is never a good idea. And the reason is very simple, that the centralized AI team is usually not connected in with the organization. Typically, what has worked is that, so you can kind of see the pattern everywhere, even in IT. So in IT, you typically see the people who maintain the servers are in kind of one location, but the people who build IT applications are more associated with the business units themselves. And AI is no different from that. And it's basically about being connected to the business analyst. If you don't have a business analyst associated with an AI project, then it's probably going to fail. Because part of the analysis is not just simply, this is an AI problem that needs to be solved, but really, what are you trying to solve? What is the business outcome that you're hoping to achieve? And that business outcome is ultimately what drives the underlying model that needs to be built. And so, but I think by understanding the business outcome, it prevents you from being locked into one particular AI model. So an example would be, actually the example we just talked about it would be an example where if you're kind of trying to build one model, you're going to be locked into it. But it's probably better to think about it from, well, what is the ultimate business objective? What are people trying to do? In this case, they're really trying to simplify their search, in which case then you don't need to build something that summarizes. You just need to accelerate the search capabilities. So part of that is like understanding, working with a business analyst, and the business analyst is the one who hopefully can tell you what is it that they want to build. And it's more, and if they're good, they're going to be able to tell you that from a business level that, we just need to minimize the time it takes for people to do this thing, in which case then you look at various options for building a model around that. An architect is needed because of the fact that ultimately it needs to be integrated and there needs to be control over the actual model that needs to be built. It's not just about, one thing is that an AI, like anything else, should never exist in isolation, which means right from the beginning you need to think about how you're going to integrate this into the overall enterprise solution, which applications are you going to be integrating it with, what kind of processes should be in place to update it, how are you going to, like if there's going to be any rapid iteration or rapid development of this thing, how is that going to be controlled? How do you interface with different parts of the organization? Typically, those are all responsibilities of an architect. And of course, you have an ML engineer, and then an enterprise SE, so which is basically just a software engineer who does the basic development and coding and kind of the plumbing of how the application is actually integrated. So the next part is really understanding the process, and determining the process is really important because every business scenario, there's an underlying process behind it. Nothing exists in isolation. So if you're working on an ML problem and you can't identify the process that you're improving, that's a problem because it means that what you're working on may or may not have any business value. So it's very important to understand what process you're working on, what process are you improving, is it an improvement, are there alternatives? And so typically the process analysis should be done by a business analyst, but good data scientists will also get involved in that because a lot of times the business analysts may not be aware of the options they have available. So identifying the process is a large number. So there's a large part of process improvement is kind of either optimizing or automating manual processes. So these would be cases where I'm trying to solve a specific, I'm trying to achieve some specific aim. It could actually be as simple as you're a restaurant and you're trying to figure out what is the best way for your serving staff to be able to reduce the waiting time for customers. And so basically, that could be either something you're manually improving because you just maybe segment out your restaurant into smaller pieces and have the waiter or waitress own that part of the restaurant. There could be other things. So basically, that would be an improvement, an optimization of a manual process, or there could be an automation task involved. So some restaurants now, you can order and pay for everything at your desk, at your actual table. So that would be an example of pure automation. But part of this is that to understand, what am I trying to do? Am I trying to optimize a manual process, or am I trying to replace it with an automated task? And more often than not, with machine learning and AI, you're not actually going to be replacing humans. You're going to be helping them make better decisions. Most of the processes that exist in the enterprise are non-documented, which is why you get these really bizarre projects that appear out of nowhere, because of the fact that people don't really realize that, there really is a process there, but nobody's really talked about it. So it's kind of good to just write it down and actually look at what is the process involved. And every activity in a business is part of that process. Paying a bill is part of a process. Being able to write code is part of a process. Everything that a business does is part of a process because you need to be able to verify, you need to be able to check, you need to be able to adjust based on the failings of that, and you need to be able to improve that. Now, a lot of times, because the processes aren't documented, you can't improve them because nobody knows anything about them. It's implicit. People understand that it's there, but they don't know anything about how to improve it. So, if you're asked to do something, then document the process that it's part of. And sometimes you're going to be creating new processes simply because there might be business opportunities or cost reduction opportunities in place. So the next thing is collecting data about the process, and these would be things like sales volume, widgets produced, customer service times, like throughput, a lot of things like that. Over here you saw things like increasing the number of subscriptions, the time and cost of manual labor, legal fees. These are all kinds of measures of processes, and typically these are known as KPIs for businesses. And so understanding how you measure a process is kind of important in terms of how you are going to be improving them. You need to understand resource requirements. So if you have a process, how many people does it take? How much time does it take? What is the cost of it? Are there equipment charges involved? And a good example is that at Intel, when I was working there, it was a very different mindset. Because in manufacturing, the moment you're committed to blocking out a fab, which is a place where they used to manufacture the chips, you're committed to that. So which means that fab is being allocated for nothing else except chip manufacturing for that period of time. So which means that if you're a day late, that fab is sitting idle for a whole day. And so, which is a tremendous waste of money. It delays a lot of other projects. So understanding both material as well as people requirements for a process, is really important. And then the last thing is also understanding the organizational information. Something that's often not really factored in is the political ramifications of what you're trying to do. So many projects die not because they're not good projects, they die because there's a ton of political backlash to that. There's a great example. It didn't die, but it really caused me a lot of heartburn when I was at Intel. So what happened was I developed, so we used AI to optimize on a manufacturing process. and we were able to reduce the cost of that manufacturing process by close to 60%. But that basically meant that an entire team in India would have lost their jobs as a result of that. So I came directly into head-to-head conflict with the head of that team. So he was basically, he had absolutely no incentive to help me implement my solution, because he would have lost half of his team in the process, or actually most of his team in the process. And so I had trouble actually getting him to getting a good example of something that would actually, like a real process. So then eventually what happened was another team based out of Germany, they were a new team. So they had no team built up or anything. So they decided to go ahead and implement our process. And what we predicted in terms of cost, it was exactly what they got. So which means that we would have been able to achieve the same sort of cost savings for the other side. But where I failed in that project was I didn't get political backing for what I was supposed to do. So which meant that if I'm going to replace an entire team with my project, I need to be able to figure out, how do you message that better? How do you kind of get this person's cooperation? How do you basically, I mean, he was clearly there. I mean, he measured his own success by the size of his team, that's the way a big company works. And so I would have basically, it would have been a tremendous loss of face for him. So that was an example. It taught me that, the building a good solution, even if it makes a lot of business process sense, it doesn't really, you still need to think about the organizational ramifications. The other thing, for example, medicine, I was talking to some physicians recently, and they were like panicked that they were like, "Oh my God, your system's going to replace what we're going to do." It's like, we're not going to, we're not going to be needed. A radiologist won't be needed for this. But no, it's not. It's actually going to be, this is actually in Germany, not the other project. That's actually not going to be the case, because this is a decision support project. So which means that it'll help the physician make a better decision. So large part of it is kind of how you present it. So in terms of analyzing processes, the things you're looking for are bottlenecks. So bottlenecks continuously shift. So everyone knows what a bottleneck is, but the thing about bottlenecks is that the moment you clear one bottleneck, you create another one, because there'll always be a part that's the least efficient out of that group, or least has the lowest throughput in that group, and so you're going to look at improving that. There's a really good book by Elihu Goldratt called The Goal, where if you're really interested in process improvement, that's actually it's a good book to read. Performance issues are things to look for. Performance issues could be time to get things done, so that is related to bottlenecks, but it could also be in general that the entire process takes too long, or maybe the other thing could be it's too expensive, the equipment you're using is too expensive, it could be that the resources you're using is too expensive, many things like that. Maybe I'm depending too much on external resources and I could maybe bring this inside. Gaps, it's basically what is expected versus what is actually delivered. And so there are cases where there are gaps in terms of what expectations are. And then obviously quality is a factor. So then the final part is developing an improvement plan. And so automation is one of many different possibilities. Resource optimization is another, which means optimization is about removing people. To some extent, resource optimization is to help people do their work more efficiently. Adding steps, which means that can I take steps out of somebody's day? On the other hand, it could be that if you added an extra step to this person's work schedule, they could improve the quality. And then also looking at capacity improvements. So, for example, how do I increase the effectiveness or throughput of a certain team? So, questions to ask. So what is the business opportunity? The next question is like, what business process transformation can I use? Operations optimization, digital transformation. Digital transformation means taking a process that was done previously manually and either like making it electronic. An example of that would be back in the day, you'd call the corporate travel center. They would book your trip and hotels and everything for you. That changed because now everything, you just go to a website and do everything do everything manually, digital transformation. And also legacy modernization. Right now we're talking to one customer. Their systems are stuck in the 1960s. And so they really want to make a huge step forward and go from the 1960s manufacturing to actually using AI to determine kiln temperatures and things like that. So, which is so determining what is the optimal way to increase the quality of their output. Then can you measure the impact? What technologies have solved similar problems? As much as possible, leverage things that people already have used before. Don't try and kind of reinvent stuff. That's can be used for everything. Then do you have the resources? Machine learning, typically, that's a huge bottleneck right there. Having the right authority. This is basically a very fundamental aspect of getting any business problem solved. And the last part is, are ethical issues. This is oftentimes forgotten, but these can really bite you as a business. An example of that is if you're an insurance company and what you're doing is, suppose you fill out a risk assessment form, and then the insurance company goes off and looks at your social media page, looks at anything else out there to determine. So you say, I don't smoke, but then suddenly there's a picture somewhere of you smoking a cigar. And that's kind of a bad thing because then it increases your risk profile. Or basically assessing, determining from metadata, so using sort of meta-analysis to determine somebody's sexual orientation or determining whether somebody's got a drug problem or a mental illness or something like that. All of these things are things that are borderline questionable. And of course, there's the entire thing about the military and the defense industry and whether or not it's okay to issue a kill order and all of that. But beyond that, there are some deep ethical issues that need to be resolved. And a lot of times, businesses can get really badly burned if the output has been not thought out, I'd say.